Okay, so this video is going to represent what we're going to call 6.2, which starts to look at similar shapes and similar polygons. So we went over some examples of proportions, and now we're going to apply that to shapes, because what we're going to find out is similar polygons are not congruent polygons, and they have some qualities because of that, but they also are not the same size. And what we're going to find out is their sides are proportionals. So polygons that are similar have the same shape and size, and we'll talk about that. Oh, sorry, same shape but different size, of course. All right, so in some sense that means they look the same, it's just one is bigger than the other. Now, polygons are similar if two things are true. One thing that stays true is that corresponding angles are congruent. So the angles don't change, okay, because that's what keeps it the same shape. So everything has to be headed in the same direction. You know, the different lengths head off in the same way, look the same way. So the fact that angles are congruent keeps them looking the same, okay? So that keeps them the same shape. However, they do have a different size, but there is something that's consistent with the size, because corresponding sides are proportional. Okay, so that means they go up by the same scale factor or down by the scale factor. The ratio of corresponding side is called the scale factor. Okay, so you can go up by a factor of 2, you can reduce by a factor of 1/2, and that is how all the sides have to be changed in order for them to remain the same shape. It says if polygons are similar, then their perimeters, because one thing we'll look at, are also proportional. So that can kind of make sense, right? If I increase all of the sides, I double all of them. Does it make sense that the perimeter is also doubled? Okay, perimeter meaning distance around. So if every length gets multiplied by 2, I think the whole perimeter gets multiplied by 2. All right, so let's look at this next one here then. Now, the same thing applies, all right, here when I look at A, B, C, and D, E, F. So we do go by letters, all right, and they do have that mark. Notice that A is marked with D, and so on, okay? So the sides would be the same. So it says, what is the scale factor of A, B, C to D, E, F? So let's make sure we're comparing like sides. So if I take AB, okay, what does that correspond to? AB is going to correspond to DE, right here. So what would that scale factor be? Now, if we're being technical, from ABC to DEF, it's getting bigger, okay? Now, we can flip it around however we want, okay, as far as that goes, all right? But if we look at it here, it says, what is the scale factor of ABC to DEF? What they want us to do is compare, this way, okay? So that means I'm going to have 8/12. Okay, and then it is nice to reduce that ratio to 2/3 if you divide both by 3. Now, what's the scale factor of DEF to ABC? All right, so again, if we look at it there, how does that work? Again, we flip it over, it's getting smaller from 12 to 8, which means the scale factor would be 3/2. Same ratio, just flipped over. And then, of course, what is the perimeter? If you understand how the perimeter works, the perimeter should be the same as this, okay? Because if the perimeter gets bigger, how much bigger does it get? It gets bigger by 3/2 derived from the 12/8, okay? So again, we can compare sides. So that would be a 1.5 scale factor going small to big. Most people like to go from small to big. That makes more sense, but obviously if you were to go the other way, it would be the reciprocal, which would be 2/3. Okay. All right. Now, a validity statement must match the corresponding sides. And it says write a similarity statement for above. They kind of already did it for you, but what that would mean would be if we wanted triangle ABC. Now, here's the similar sign. Okay, the similar sign is one squiggle. Notice there's no equal sign. Okay, is congruent, then we would match up the angles, right? So A is with D, B is with E, and C's with F. So the order of the letters, just like the last time, does matter. And the similarity statement's going to be a squiggle right there. So if you look down here, we're doing the same thing again. We're going to match things up again, not by looks, okay, but by letters. So if these are similar, then what happens here is as far as the angles go, right? Angle J would be congruent to angle P, right? Because the angles are congruent. Similarly, angle K is congruent to angle M, and of course, angle L is congruent to angle N. Now, what about the sides? Okay, the sides are proportional. All right, so one way to write this is sort of with a longer proportion. So I'm going to say JK over PM. Do you see where I got those two from? So JK and PM, that ratio is equal to, guess what? It's equal to KL over MN. Okay, it's equal to KL over MN. And then if you can follow, the last one's always kind of weird, right? Also congruent to, equal, the ratio is equal to JL and PN. Okay, all of these ratios are equal. So just like up here, when we found this one is 3/2, guess what the ratio of all the other sides are? They're all 3/2. So the emphasis here is all the angles are the same and all the sides are proportional. All right, let's try to apply that here a little and see. We're going to skip over those. Just one thing real quick here. If you look here, do you see this also applies to non-triangles? So I could have a quadrilateral, that's called 4 sides. I could very easily match up all the angles and match up all the sides. I guess I'll touch on this real quick. This is a very common problem. Does everybody see the 2 triangles here? Here's one, the upper one, and then here's the other one. It's here. Now, what do you notice about this? Well, they both share angle Y. Okay, and we'll talk through that when we do some examples in class. All right, so down here, let's apply a little bit of this then with the scale factor. So for number 4, if this has a scale factor of 2 to 3, okay, for this, how would this go? Well, okay, so if I had 42, I could set this up like a proportion, right? So the idea would be of 2 to 3 is 2 to 3, and again, we're going to set this up like a proportion. Now, the thought process here is which one is smaller. Now, you can take that from the picture. Do you agree the 42 is smaller than x? Okay, so do you agree the small side has to go with the small side? So I'm going to put 42 here and x on the bottom. Now, remember how you solve a proportion. You're just going to do the cross. If you do the cross, you know, divided by the cross, you don't. It's a little bit quicker on your calculator. But if you multiply it all out, you'll get some version of 2x equals 126. But if you do it all in your calculator, you're going to get x equals 63. Okay, as far as that goes. Now, down here, let's look at number 6. Number 6, if triangle ABC is similar to DEF, find the value of x. This time we just have to make sure we get everything in the right order using the letters again. Okay, so what I do is I'm going to put this triangle in one proportion and this triangle in the other proportion. So I'm going to start with this. So I'm just going to pick 28 over x. Okay, and this is how I do it. So I'm going to do 28 over x. Now, what I would look at here then is what does BC correspond to? BC corresponds to EF. So I'm going to put the EF value here with the 28 across from it. And then AB, right, corresponds to DE, so I'm going to put the 25 down there. Now again, on your calculator, if you want a shortcut, you can do the cross you know, divided by the cross you don't know. But if you were to do that, right, you would get some version of 20x equals 700, I think it turns out to be, which would tell you x equals 35. So again, if they just give you the ratio in 2, you can do this. If they give you the sides, you want to try to match them up across from each other using the letters. One quick note here, it does apply to quadrilaterals as well. Okay. Now, let me look at let's go down to just number 10, because we'll come back to some of these. So this is your algebra part again. It also applies to algebra pieces. So again, I'm going to use my letters. Now, the way I would consider doing it is, I'm going to take this and make a ratio out of this triangle, okay? So I'm going to choose for this one, okay, I'm going to choose, let me see, yeah, that's fine. I'm going to choose 36 over 32. That order doesn't really matter. What does matter is I match them up over here. So if I do this way then, right, so the 36 is GM. So I go up here and I say GM is the same as xd. So I'm going to put x plus 6 straight across from it. And then 32, which is GA, okay, or AG, that's going to be KX. That's going to be the x plus 3. Now, just a reminder, this one, you have to do it algebraically, right, when you put it together. So if I multiply here, I'm going to get, I'm going to get 32x plus 192, if I do this cross, is going to equal 36x, right, if I do this cross, plus 108. So just remember the distributive property there. If I move things around, I'm going to get some version here of 4x. By moving it that way equals 84. Hopefully you can follow that algebra. And I'm going to get x equals 21. So for that one, that is not a calculator problem. What you need to be able to do is set it up and do the distributive property for that one. Okay? So that's the basis for the lesson here. We're going to go through some of these as we go. We're going to talk about number 12 in class then too. But if you can write down those notes and come ready for that, we'll go